Hey y'all, I have our first video request I'm working on from my friend Michael, and he'd asked me to go over diesel fuel systems because they're a little bit different than gasoline, not too much. So we're starting out here in the salon. One thing we're going to look at is I always carry a spare set of filters. We will go down in the engine room here shortly and take a look at some other stuff, but here are the filters we use. There are 4 of these cartridge style filters that go into the Raycor filters, and there are 1 each of these canister style filters that go on the engines, right? So um, these filter out big junk. They also block water. There's a cyclonic filter. I'll show you that down in the engine room. These are what people call the last chance filter. They also filter down to a finer micron, and they spin on right near the fuel pump. These are annual service items if you aren't running a lot of hours on your boat. Obviously, the manual says, hey, you should change these at these times. But ultimately, one of the things that was also requested in the video was talking about fuel polishing. But I'm just going to go end to end on the fuel system. The fuel system consists of storage, meaning your fuel tanks. We'll show you those down in the engine room. It consists of fuel level, which are senders that are inside the tanks and then read out at the helm to tell you how much fuel you have. Then there are transport lines that run all over the boat. There are valves that change where the fuel is drawn from. You are able to draw fuel from either engine off of either tank. So for instance, if you went single engine on a trip, you could burn all the fuel on the boat out of that one engine. The other reason you have the ability is to balance tanks, because on this boat, particularly, the generator only runs off the port tank, meaning if you run your generator dock to dock like we do, oftentimes you do need to burn both engines out of one tank to level the boat out. Fuel is heavy, roughly 7 pounds a gallon for diesel, and that, after 20 or 30 gallons are off on one side, obviously the boat will start to list a little bit. So we'll start at the valves that are underneath the stairs. Then we'll go down into the engine room, look at the tanks. We'll look at the filters. We'll look at the fuel pumps, and etc. I kind of stopped at the filters and the transport lines on the fuel system. There are 2 fuel pumps on this particular boat: a lift pump, meaning the pump that moves the fuel from the tank to the high pressure pump, and then there is the high pressure injection pump. We'll be able to see all of those. There's different kinds of fuel injection systems, and we'll talk a little bit more about those as we go, but it's interesting. So you're going to see a high pressure P7100 pump on a Cummins 6 CTA engine. Pretty standard diesel setup. Now, Caterpillar's always used what are called unitized injectors. I shouldn't say always, but they use unitized injectors, meaning the injector itself is the pump and it's inside the head. Then, as technology developed, Navistar or International built the HUI, or the hydraulic electric unit injector, where they used high pressure oil and a solenoid to drive the pump. And then there's been several other advancements, piezoelectric, et cetera, et cetera, et cetera, et cetera. Most things have gone to unitized injectors at this point, meaning each injector is its own pump and metering device. Our boat is a little bit older, fully mechanical diesel, so it's a little bit different, but the concept is the same. You move fuel from the fuel tank, it goes through filters, it is pumped, it is then injected, and then the other interesting piece about a diesel is that it returns some of the fuel that is not used back to the tank. And this does what's called polishing fuel. So what's always happening is you are moving fuel from the tank, it is going into the engine, it is then being used partially and then sent back to the tank, which means you're constantly pulling fuel through the filters and polishing it. So if your fuel gets algae in it, if it gets dirty, if it has contaminant, the problem with that is what happens is your fuel filters will plug up rather quickly, and that's what they're supposed to do. These cartridge filters here have a special coating on them to help repel water. And then that is also spun out not only for water, but for particulate in a cyclonic filter. Again, I'll show you the Raycors down in the engine room. And these also just block particulate. You do not want particulate going into your fuel pump or into your fuel injectors. The holes on those injectors are very, very small. So that is a rough overview of how all of that works, and now we'll go look at the individual components. Okay, as promised, we're outside here. A little bit windy. Mind my mess. It's where I keep all my detailing and for stuff as well. So in here, we have a fuel panel. And you can see both the port tank and the starboard tank, and then you can see the generator switches down at the bottom. So the generator switches, as I said, only feed off of the port engine, but this is where you can select so we're taking the starboard engine is currently running off the starboard tank. If I move this valve like this, now the starboard engine is running off the port tank. Again, something we would use if we were running single engine or we're trying to balance the tanks. So oftentimes I'm taking the port tank or the port engine over here and running it off the starboard tank, again, because of that generator imbalance. Obviously, the valves allow you to shut off fuel to any of these systems. So it's kind of a maintenance item. I often do is I come in here and I just move those valves, make sure everything's flowing. You've heard me say it before. What gets used continues to work. What does not get used breaks. So that's really where it starts out. Those are the valves that control the fuel out of the tanks and into the engines. So now we'll get into the engine room and we'll take some shots and go over the transport lines, the filtration, and the fuel pumps, and just a little bit of diesel engine theory. All right, y'all. Down here in the engine room. So you can see there's a lot of lines on these boats, but a lot of our fuel lines are just running overhead, but they come in, so they come from that valve and they go to this filter. This is the Raycor filter where those cartridge filters went. And what's interesting is that Raycor filter allows you to select either side. The proper way to use these filters is to run on one filter and then every month flip over to the other to move those through. What that does is it gives you the ability, if you get bad fuel, to flip that handle and keep running on the other filter, right? And you don't plug both filters at once. It also increases the flow rate through the filter, so that you can see down there where the dyed diesel is, you can see those different components. And what that does is that spins the fuel and creates a cyclonic effect. Again, inside the filters have a special substance on it to help block water, and then that water then falls into the bottom. You can drain out of those bowls, and that's where you're going. So from there, the fuel flows out to the engine. So there's an inlet and an outlet line on that block where you saw that yellow handle. It then comes over to this component right here, which is a lift pump. On this particular engine, this lift pump also has a manual priming pump. And you hear that squeak, you know you're primed. That's always good. You don't want to come down here and do that. And so this is just driven off a cam inside of the fuel pump. This big monster up here with all these pipes on it is the P7100 fuel pump. Right here is your fuel shutoff solenoid. If for some reason that fails, you can actually come down here and manually move this to get your engines running, and vice versa. If it won't turn off, you can undo this and flip it the other way. Here's your throttle. This just moves back and forth based on the throttle position on the helm. All manual on this boat. And what that does is it controls how much fuel each one of these injects into the injectors, right? The fuel injectors are on the other side of all these lines into the heads up here. Can get you a quick look at one. And then you see there's two pipes here, right? One is your injection line, one is your return line. There's also a return line off of this pump. So really that is it. The other cartridge filter is here on the engine. You can see it right here, the same one. I never make the claim that my boat is perfect. Obviously, I work on it pretty often, but at the same time, we use the boat, so it gets dirty, and these engines are old, and they leak a little bit. So that filter just spins on there. And then this is the fuel cooler here. It actually uses water to cool the fuel. It's the first place the water comes off of the raw water pump. So I have the storage outboard here, and let me look at I can show you the fuel tanks here. So the fuel tanks are those big gray things. You can see one of my control cables going to the transmission. That strap is holding in the fuel tank. And then here's the fuel tank on the other side. They go basically the length of the engine room. So that is the fuel system. As I mentioned, because I showed you those return lines, what happens is that lift pump that we looked at continually pumps fuel to that high pressure fuel pump, pulling fuel through the filters and then returning it to the tank. And it just does that all the time. So it's constantly polishing the fuel. Again, there's different kinds of injectors. There's the mechanical injectors, which you just saw. And then I think, interestingly enough, about diesel, a little bit of diesel fuel theory is engines are timed by fuel injection, not by spark. So, compression ignition engines superheat the air, and then the fuel is injected at the time that you want the injection to occur. Whether that is on this pump right here, which is clocked to a certain time to the engine, and that is all timed out inside of that, or it's a unitized injector, or like on some Cat engines where there's actually what looks like a third rocker arm up in the head that actually taps the top of the injector and causes that injection event. Or if you get to the more modern hydraulic electric unit injectors or the piezo-driven injectors, they can do some pretty wild stuff with up to 7 or 8 injection events per cycle. That's why you hear some of the more modern truck diesels are very, very quiet. But ultimately, fuel in diesels are interesting in the sense that you can run the compression up very high because you don't have to worry about pre-ignition, right? So that's important in a compression ignition engine. In a gasoline engine, gasoline air is all pulled in on the intake stroke. It is all compressed together, and then the timing is driven by the spark lighting that off. In a compression ignition engine, just air is drawn in on the compression or on the intake stroke. On the compression stroke, it superheats the air, and then the injection event from the fuel injector then causes the burn of the fuel in the air, and then you have that power stroke as that piston is pushed back down. So just a little bit different than gasoline engines, not wholly different, but a little more tolerant of high compression and things like turbochargers and being able to really run the cylinder pressure up, which contributes to the efficiency of diesel engines. So there you go. That's the diesel fuel system in a nutshell. Starts with storage, goes to some valves, heads to a filter, at least one set, if not two. The lift pump pulls that fuel up to the engine. Sometimes there are fuel pumps in the tanks or not on the engine that are lifting that fuel. It goes to a high pressure fuel pump of some flavor, whether it's like my mechanical P7100 right back here, or it is a individual pump inside of injector, like a unitized injector. Then the engine is timed based on different things. It could be a crank position sensor. It could just be a physical spline of the pump. The injection event occurs and you make power. So really a much more efficient engine, primarily because of the compression, primarily because you don't have fuel and air mixed during the compression stroke, allows for a much higher cylinder charge. So there you go. I hope that kind of demystifies how diesel fuel systems work in boats. We'll absolutely do another one about diesel fuel system maintenance, which talks about shocking and algae and cleaning things and using different fuel lubricity additives, especially if you have older diesels. But hopefully this was helpful for you. If it was, hit like and subscribe, ring the bell so you don't miss any more. And please check out our other videos that are on the channel. Appreciate y'all being here and look forward to having you here in the future.